All right, sounds good. We're gonna get busy, guys. All right, so what I'm gonna do here, we're obviously in lockdown with coronavirus, so I've taught physics of flight for years now. I've done this many times in the classroom before. A lot of kids have heard my little presentation on physics of flight. So I figured this would be a good way to conduct my little discussion with you at home while we're waiting out this COVID-19 thing and our lockdowns. Anyway, I'm a captain at Southwest Airlines, and I also own this little company, STEM+C. My specialty is aviation, aeronautics, and aerospace. And I'm also an RC airplane flyer as well. Today, the first lesson is going to be a quick, maybe 10-15 minute little lesson because I don't want to bore anybody to death. But we're going to talk about the forces of flight. And then in the later discussions, we'll talk about those individual forces and the theories behind them. So let's get started right now. I've got my airplane up here, my Southwest airplane. Hopefully I don't get into trouble from Southwest for using a Southwest airplane. But anyway, if you have any questions at all during the discussion here, leave them in the comments. I've got my crew that's working behind the scenes. They're going to read me the comments or the questions. So as you have questions, feel free to post. I want this to be interactive. I don't want this just to be me talking to you. Anyway, let's talk about the four forces of flight. And usually when I do this as a live discussion, it's very interactive. I just bring the answers out of the students. So we're going to get started. Let's talk about, and I'm going to say this, everybody says the four forces of flight. But you're going to learn here, Paul Kaup says there's five forces of flight. And I hope all of you remember today, the takeaway from today is there are five forces of flight. Without these five forces, an airplane would not fly. So let's get started. All right, first force of flight that we have is the weight of the airplane. So the airplane has mass, it weighs something here on the Earth. Earth's gravity is pulling down on the airplane. So the whole airplane is being pulled back down toward the Earth, toward the center of the Earth. So actually there's force vectors all around the airplane. We sum up all those force vectors in an area called the center of gravity. The center of gravity is going to be out here somewhere roughly on this airplane. This is what we call weight. Our next force that we'll talk about is called lift. Lift is the force that the airplane needs to generate in order to overcome weight. If we don't generate enough lift to oppose weight, the airplane will not get airborne at all. So our next force of lift is generated by the wings, and it's also somewhat generated by the body of the aircraft. And we'll talk about that in a later discussion. But for all practical purposes, we sum up all those forces that the wing, the lift force of the wing, is creating. We call that lift. We also need a forward force. That forward force can be produced by a propeller. It can be produced by a jet engine. It can be produced by tossing a paper airplane. So we need some type of forward momentum, and that forward momentum is called thrust. Well, let me get a different color marker here just to stay consistent with my using different colors. So the third force, thrust. The last force here is a force that we call drag. Drag is a drag. Drag is the force that opposes thrust. As we move forward, as the air molecules in the air impinge on the surface of the airplane, and also as a little bit of a byproduct of lift, a rearward force is generated, and that's called drag. So there you go, we got our four forces of flight. But when we talk about the four forces of flight, this airplane will not fly as I've got it drawn here. This airplane, if you see, we have lift, weight, thrust, and drag, and we can label our thrust there. I didn't. Okay, here I got one of my favorite RC airplane companies or educational company, whatever you want to call it, Flight Test. This is just a flight test chuck glider called a Raptor, F-22 Raptor chuck glider. This string here is going to represent the lift vector. So lift coming up being generated by the wings. This string down here is going to be my weight vector or my center of gravity. If I just have these two forces, the airplane wants to tip nose down and lunge out into the ground. If we only talk about these four forces and specifically these two and how they're working together, this airplane will nose into the ground because there's nothing to balance the airplane here. So we need a fifth force. And that fifth force is called the balancing tail load. That balancing tail load is produced by the horizontal stabilizer on the back of the airplane. And I'll label this BTL, balancing tail load. Now, when I have my balancing tail load and I have my lift acting up, the airplane is stable now. So here, this string here is weight acting through center of gravity. This string at the tail, that's my balancing tail load. And you can see as I'm pulling it, I can change the direction of the nose. I can make the nose go up, I can make the nose go down. That's how the elevators on the back of the airplane work. Those control the nose pitching up, the nose pitching down. So in your physics classes, your science classes, whenever this comes up about physics of flight, chime in that there's not four forces of flight. Tell your instructor, your physics teacher, that you once learned that we need a balancing tail load to offset, or not to offset, but to balance the airplane. So I know right now in the crowd, some of you are saying, well, wait, Mr. Kaut, that airplane does not have a tail. I agree, that airplane does not have a tail. I have one of my wing airplanes here. This happens to be a RC airplane, obviously. This is a right wing airplane called the Nanodrak. It is a wing airplane. There is no tail on this airplane. Yeah, we have these on here, but these are vertical stabilizers to keep the airplane vertically stable about its yawing moment. Anyway, the way this works is even a wing aircraft has a balancing tail load. So on this airplane, my lift vector is going to be like right about here. My weight vector is going to be right about here. So I got lift, weight, and now you say, but wait, there's a balancing tail load. Where is it? Where is it coming from? In a wing airplane, we have something called reflex. Reflex is the amount that these are called elevons on a wing airplane. Those elevons are actually tilted slightly up. So here I have my wing airplane. Oh, I'm a horrible drawer, guys, stick with me. So here's my wing. On a wing airplane, the elevon is actually tilted slightly up so that it creates a balancing tail load. This is called reflex. So this airplane does have a balancing tail load. The balancing tail load is being produced by these elevons, and if you can ever so slightly see that in the video, the elevons are not completely flush with the wing. They are slightly up on the back end there. This airplane will not fly without reflex. It'll launch out right into the ground. Anyway, this airplane flies no different. The forces of flight, the physics of flight on this little glider is no different from my airplane at work. The only difference is this one takes a lot more thrust to fly than this one. So that's it as far as talking about the force of flight. So if anybody asks you in the future, there is not 4 forces of flight. There are 5 forces of flight. Okay, so next, take question. I guess there's one question. Bun, go ahead. What's the question?
Somebody said, Peter said, isn't that just using drag and weight?
Peter said, isn't that just using drag and weight?
For the balancing tailwind, I think.
Isn't that just using... I'm not sure what the question is. I don't understand it. Isn't that just drag and weight, he says? Isn't that just drag and weight? Well, let's see here. Drag is the force that's opposed by thrust. So as the aircraft, right now, this airplane is in steady state. The only force acting on this airplane right now is weight. Gravity wants to, if I pull my hand out from underneath, this airplane's going to hit the ground. Now, if I give this airplane a good chuck and a toss, it will fly, even without the motor going. It'll glide for a little bit. It'll eventually return back to Earth. So those same air molecules that are allowing lift to be generated by virtue of airflow flowing over the wings, those same air molecules are causing drag on the airplane, and that drag is the air molecules bouncing off all the surfaces of the airplane here, and the airplane will eventually settle back down and return to Earth. Hope that answers your question a little bit. Peter, we got another question. Go ahead.
Peter's clarifying, I'm not sure that is a 5th force. You're explaining flight surfaces using drag.
So I would argue that yes, Peter's saying that he doesn't necessarily know if balancing tail load is a force of flight. I would argue it is, because if we take away balancing tail load, and I know it's all theoretical, and you'll see when we start talking about lift, if some of you stick with me, you'll see lift is a controversial topic in itself. So in my world, in Paul Kalp's world, this airplane does not fly as it's drawn here. And Peter mentioned something else that I'll go off on here too. I absolutely hate when this drawing is drawn like this. The reason why I absolutely hate this, and you see it in so many textbooks, is it's already setting up a misconception that weight is directly under lift, and that is not the case. In fact, if weight is directly under lift, this airplane's it's not gonna be stable. In fact, it's gonna be very twitchy, very pitchy, and you may not even be able to fly this airplane. So the correct position to draw our weight vector is out here. And this is why even in the RC airplane world, okay, or in the heavy airplane world, such as 737 or 747, anything that flies, this weight vector, we calculate where that weight needs to be. We do this through a weight and balance program. And this weight vector needs to be out forward of our center of lift by a given distance. It's going to be different obviously for every airplane. Anyway, our work computers at work calculate this, and our ops agents calculate where they need weight to be in relation to lift. So they load the airplane with the bags appropriately and the people appropriately and the fuel appropriately so that our weight vector is out here. This airplane would not fly if our weight vector was back here. This airplane would not fly at all. So weight is always out front of lift. Now, the reason why I say there's 5 forces of flight and not just 4 is lift is a product of the wings to offset our weight. This airplane right here, as it's drawn, will not fly. It's inherently unstable. We need a counteracting force, and that counteracting force is what's called the balancing tail load. So, again, it could be argued in the aviation world about how important the balancing tail load is. Paul Kelp says it is very important because none of these airplanes will fly without a balancing tail load. Any other questions out there? So I think that was it for questions. Let's see. So I'll do these again if people want, just quick little 10-15 minute discussions, and if people want to comment and interact, that's a great way to keep this interactive, I guess. Anyway, I enjoy doing these videos and I look forward to doing some more. And for those of you that are interested in high school in aerospace, aviation career or aeronautics career of some type, I look forward to doing some discussion videos on helping you with your career as well. Anyway, thanks for tuning in today, you guys. Oh, wait, we got maybe one more question.
One more comment.
One more comment. We got another comment. What is it?
You better read it.
All right, so we got another comment here. What do we got? Sorry, C17. Visible demo when a C5 gets balancing. I don't see a question here.
Oh, isn't that a comment?
I don't see a comment. Nope. So I think that's it. Thanks, y'all. Go ahead and send me, keep commenting in the comments section, and it only helps me to learn some more too, because by no stretch of the imagination am I an absolute expert at this stuff, and there's always room to learn. And wait until we tackle this one, lift. If you want to cause some water cooler